All right, welcome to tonight's lesson. So this is just at the outline, the content of what we're going to cover this holiday. Yeah, so this is just for mathematics, and then for chemistry, we'll do that tomorrow, and then physics on Friday, according to the timetable. All right, so like I said, you need to make a payment of 100 kwacha for this course. For chemistry, it's also 100, and physics too. Yeah, so it's 100 kwacha for each course. Yeah, and that's a monthly monthly charge. All right, so these are some of the contacts that you can use to make the payments. This is my Airtel line, MTN, you have Zapid, FNB. You can use all these payment methods. Yeah, so if you are outside Zambia, if you are not able to use mobile money, you can just request for my details, and then I'll send you my NRS and everything so that you can use. I would say it's a bit difficult because it consists of very long formulas that you need to master. Yeah, but the way I teach, I'll not only show you formulas, but I'll also help you to derive them so that even as you are writing the formula, you know how it came about. Yeah, so I'm going to help you to do that. Yeah, so we're going to start with analytical geometry and vector analysis. So under analytical geometry, we're going to look at the straight line. From there, we'll look at the circle, parabola, the ellipse, hyperbola, and we look at some examples. And then the other thing I forgot to tell you is that every after a lesson, I'll always be giving you an exercise to test your understanding. Then if I see that you've not gotten anything, or if I see that you have a problem somewhere, I'll always be finding means by which at least I help you to understand that. So just make sure that you make payments so that we continue learning together. Yeah, so I'll try by all means to finish the whole syllabus before we finish, because mathematics syllabus for semester 2 is a bit short if you guys are understanding fast. But if at all we're going to be taking a lot of time on a single topic, we might end up not finishing the whole syllabus. All right, so those that have their mics unmuted, please mute yourselves. I'm trying to mute everyone here, and it seems it's not working. So just mute yourself to help us. All right, so the next topic we're going to look at is what's this? Vectors. So for vectors, our main focus would be 3D, which is 3-dimension, because I believe in physics, you guys did 2D. Yeah, at the beginning of the semester, 2D and even a bit of 3D. So I'm not going to take a lot of time on vectors because whatever that you did in physics is exactly what we are going to do here. So in physics, on this topic, we just look at the direction cosines and the vector operations. Yeah, so the other topic, after what's this vector analysis, we are going to look at further complex numbers. So I believe the person who was teaching you mathematics last semester introduced complex numbers. I don't know if they did or not, but one thing I'll tell you is before I start teaching every topic, I always make sure that at least I give you like something like a foundation of that topic. So what I imply by that is I'm not only going to skip the the basics of complex numbers. I'm going to assume you guys don't know anything about complex numbers, and I'll start from the basics, and I'll make sure that we cover this topic and finish before you guys open schools. Yeah, so at least if we fail to finish the syllabus, we should cover 3/4 of the syllabus. That's my aim. Yeah, so we are sure. Yes, okay. So I was saying, I want before we open schools, at least to cover 3/4 of the syllabus of the courses that we have. Yeah, so after further complex numbers, we are going to look at, differential calculus. And then before we start looking at the applications of derivatives and maybe, let me say, the introduction of derivatives, we're going to look at the introduction of calculus itself, where and okay. Yeah, I don't know why the network is bad today, but I'll work on it so that at least next time the same problem doesn't repeat. Okay, so I was saying, this is the part which confused a lot of students last semester, because there are some questions which are a bit complicated. Limits are simple if you understand them and if you have the right person teaching you. Because if the person who's teaching you doesn't know what he's talking about, you get nothing, in short. Yeah, you will not understand anything. Yeah, so limits are simple if you have the right instructor. All right, so this is the part which confused a lot of students last semester. I'm sure if you guys have a tutorial sheet about limits, you can agree with me. Yeah, and then from there, after looking at limits, we'll look at the introduction of derivatives. Yeah, that is that's a part where we're going to discuss the power rule, a few methods, the basic methods of differentiation. We'll look at the power rule. Then apart from the power rule, we'll look at chain rule. Yeah, so some of you did this at high school. So we'll look at chain rule. Then from there, we'll also look at the product rule and the quotient rule. So discuss these. Then from there, we'll look at the applications of these same rules. Let me just say the application of calculus of derivatives rather. Yeah, so under the applications, that's where we'll look at how you find the gradient of a plane curve at a given point. And then we'll also look at the increasing and decreasing functions. We'll look at stationary points where we'll discuss the maxima, the minimum, and the point of inflection. Then apart from that, we'll learn how to sketch the curves and also finding the rates of change. And then from there, we'll quickly move to integral calculus. Yeah, so we'll look at integral calculus and we'll look at indefinite integrals and definite integrals. Then we'll also discuss the methods of integration, and we'll look at integration by substitution, integration by parts, integration by partial fractions. So if you didn't understand this topic, partial fractions, it would be a bit difficult for you to understand integration by partial fractions. So I mean, this also applies to trigonometry. So if you had a problem in trig, it would be a bit difficult for you to understand integration of trigonometrical functions. Yeah, so integration and differentiation of trig functions, more especially integration. Yeah, so what we will do is that before we start integration by, integration of trig functions, I'll first run through trigonometry. But I'm going to assume you guys have not done trig, and we'll go back to trig. We'll discuss everything from the beginning up to the end of trig. Yeah, anything that is relevant for integration. Yeah, so I'll make sure that we discuss trig. Then after that, that's when we begin integration of trigonometrical functions and hyperbolic functions. Then apart from that, even let me say this also applies to partial fractions. I'll also assume that you guys have not done partial fractions, and I'll make sure that we go back to partial fractions, we discuss that, and then get back to integration by partial fractions. Then from there, we'll look at integration of rational functions, and then also integration, the application of integration, where we'll discuss the area under the curve. I also forgot one thing here, which is the the volume of revolutions. So we'll also look at that. Yeah, so this is basically what we're going to discuss under mathematics. Yeah, so I don't know if you guys have a question on the course contents. Yeah, so the topics seem to be a few, but they are bulk, more especially complex numbers. I'm sure complex numbers and calculus, I'm sure that's why we're going to take a lot of time to finish. But analytical geometry and vectors, analytical geometry, we can even finish next week, because we only need maybe 3 sessions, 3 if not 4 sessions, and then we'll be done. For vectors will only need maybe 2 sessions. And then complex numbers, this is what would take at least maybe I'll say a quarter of the holiday, and then we'll conclude with calculus. Yeah, so I don't know if you guys have a question or any questions before I can end this meeting so that we begin looking at analytical geometry today. I want us to start with analytical geometry, and under analytical geometry, I think we'll just look at the circle for tonight. Then next time when we meet, we'll continue with a parabola and the ellipse. So do you have questions before I can end the meeting? I want us to quickly begin looking at the straight line and the circle. But the straight line, I guess this is simple. Yeah, though, okay, I'll talk about it in just a few minutes before we begin looking at the circle. Then we'll finish with the circle. All right, so I was asking whether you have questions or not. So do you have questions before we can begin geometry? Do you have questions? Do we have questions? All right, so silence tells me that you guys agree about everything. So let me quickly switch to analytical geometry. So what we'll do is, this is, the time is 21:35. So I'm going to end the meeting, and at exactly 21:40, let's all join so that we begin analytical geometry. So 21:40, let's all join using the same link.